Hello friends, welcome to TEQIP GATE classes. My name is Professor Vivek Singh Rathore and I am Assistant Professor uh, working as a TEQIP faculty in Government Engineering College Bilaspur in Electronics and Telecommunication Department. Uh, Through this video lecture series, I am teaching signals and systems for upcoming GATE examination. And in this video lecture series, I have completed almost 13 lecture in module 1, and now today we have come to module 2, and this will be the first lecture for module 2. So let's first discuss what we will be going to study in module number 2, and then we'll go for further. Okay, so let's start. Okay, so I will start with here. I think let's break the gate. So second module 2 will consist of will be linear time invariant system. Okay, so see, in module number 1 we have studied what are the different types of signals, what are the different types of system. We have already studied what are linear systems. We have already studied what are time invariant system. So in this module we'll be studying about what are the properties and all of linear time invariant system, LTI systems. So see, let's see what we'll going to study. So in this module we'll be going to study first of all response of a continuous time LTI system. So we'll be seeing what are the response of a continuous time LTI system, and see when we'll see the response, we'll get to know that we are doing convolution of input and the system impulse response. So here we'll be needing convolution. For continuous time systems, we'll be using convolution integral. Okay, so we'll be seeing convolution integral. Okay, first of all we will see using graphical method, how to do using graphical method, and then we'll be going to see many more like tabulation methods are there. Okay, so not tabulation method, it is in discrete time. Okay, so there are many methods mathematically also we can do, and from derivative also we can take out convolution. So the convolution will be studying here. Okay, next we'll see some properties. Okay, properties of this continuous time LTI system. So continuous time LTI system, some properties will be going to study. Okay, and we'll see some systems which are described by differential equations also, and then we'll go for again next thing. See, now here continuous time LTI systems are there. Will same thing we'll do for response of continuous time discrete time LTI system. Okay, and then here we'll study, here we have studied convolution integral, here we'll be studying convolution sum. Okay, and then next again convolution sum we can see from different methods. We can see convolution, and then property of discrete time LTI system, like we'll study property of continuous time LTI system, we'll study property of discrete time LTI systems, and then the systems which are described by different equations we'll study. So actually module 2 will not be so much long as module 1, but it will contain major portion which are asked in the examination also, so we'll study about it. Okay, so we'll start our session, and we'll see we'll start from discrete time LTI systems, and then we'll go for continuous time, because discrete times are more easier to solve. So we'll go step by step. See, when we'll talk about a response of a LTI system, so what we'll tell you that okay, this is a system, and this is the response. Let's suppose your input is, let's suppose your input is xt, and you are getting output as yt, and this is your system. This we have studied. So yt, you can tell that yt is a response of a continuous, if it is a continuous LTI system, so it is a response of a continuous time LTI system. Let's suppose that we have input as delta t. Let's suppose we have input as delta t, and this system, we are getting some response of this system, and we are getting as output as this. So this response will be called as unit impulse response, because input is impulse, so we are getting response as unit impulse response, HT. Okay, so see, this is in time domain. If you'll do in discrete, means it is in continuous time domain. If you will do in discrete time domain, you'll get like this, h of n. Okay, so these both are called as unit impulse response. Okay, fine. So let's suppose that if we are shifting it, let's suppose, because as it is a linear time invariant system, so it won't vary with time. So if we will shift with something, it will obviously produce the same shift in the output also. So h n minus k will be produced. If delta n minus k is the input to the system, the output will be h n minus k. Okay, fine. Now if as because it is a linear system, linearity means it will obey homogeneity principle also. So if we are multiplying some factor with our signal and we are just sending it, obviously the same factor will appear in the output also. So it will come like this, hn minus k. Fine. So I hope you are getting it. So now if we are adding it, means if we are doing integration of it like this, from n is equal to, or k is equal to, because fk is there, so k is equal to minus infinite to infinite. So here will also appear, because what we it is a linear time invariant system, so linearity will satisfy superposition theorem also. So in superposition, if we are adding also and we are sending, the output will come. So here also we will get the same output as minus infinite to infinite. Okay, this we need, actually this we need, because as you know, see, any signal if it is multiplied by delta n minus k, you can understand, because I have explained you this property in while studying impulse response also, multiplying something with delta, if it will come here. So see, if some signal is there, if I will say in time domain, if signal is there, if it is multiplied with delta t is equal to 0, means for delta t it will come f0. The ft is there, okay, ft is there, multiplied by delta t, it will come as f of 0, because it is delta t minus 0, so f0 will come into delta t will come. Like this here also, if f k is there, it is multiplied by delta n minus k, and some integration is happened, so this term will come as f of n. Okay, f of n, and f of n will be the response. See here, what we are getting here, this is giving us this response. So in general, fn means fn will be the response of a discrete time LTI system for input k is equal to minus infinite to infinite fk h n minus k, basically this. Okay, so basically this is actually the response of, because as you know that this is a system of unit impulse response only we are taking, so it will be will be one only. So finally this fn can be said as the response of a discrete time LTI system. Our fn can be said as the response of a discrete time LTI system, fn है ना. और fn की what is the fn value? It is nothing but summation of k is equal to minus infinite to infinite fk into hn minus k. So actually what we are doing, we are operating two signals here. If you see, there is one signal fk and there is one more signal hn minus k. There are two signals. So what we are doing when we are operating two signals fk and hn minus k, what we are doing, we are actually doing convolution. Okay, so you may get doubt, sir, what is actually convolution? So I'll tell you, convolution is actually a mathematical operation. Okay, it is a mathematical operation. Okay, see, mathematical operations are performed. So it is a mathematical operation performed on two functions. Okay, and that produces a third function. Okay, so see, what we are doing, we are doing convolution. We are doing some mathematical operation on two functions, and that is producing a third function that is called as fn. Okay, so one minute. So now we'll see in while seeing the diagram. See, we are giving input to a system, and we are getting some output. Let's suppose we are giving input as fn. Okay, we are giving input as fn, and as you know, see, whenever we are giving input as impulse, and what we are getting output as impulse response, that is actually the transfer function of that, because a transfer function is ratio of output by input, and whereas see, transfer function is basically Laplace transform of output by input is there. Okay, when initial conditions are 0, so you'll do the impulse response means this, you'll take transfer function, you'll definitely get, because see, impulse response is delta t, and that is identity signal, so you'll get like this only. So whatever output you are getting here as impulse response, that is actually this one only. So impulse response, you can do it as h of n. Okay, now what you need output is, let's suppose, y of n. So now you can do y of n will be equal to this one, the equation which was this one. That means what we need to do here, do here, just f will change the domain, f n from n to k will do, h of n minus k will do, and then we'll do summation of k is equal to minus infinite to infinite. So this is the actual response of a discrete time LTI system which we were talking about. And this is also represented as y of n is equal to f of n convolution with h of n, है ना? This is represented as like this, and this both are all equal only. So you can understand that in convolution, what we are doing, we are getting the response of a linear time invariant system. That is just we are doing convolution or mathematical operation of one signal with another signal and getting third signal as a response. So now you can understand fn and hn was there, you have done fk and hn minus k. So ultimately, what in convolution, what we need to do, so in simple step I will tell you, whenever you have been asked to convolve two signal, let's suppose fn is there and convolution with h of n will be there, and you need to convolve. So first step what you need to do is you need to change the domain. So you need to change f of k is there, okay, and h of k is there. Okay, fine, h of k. Now second step we need to do, just keep the fk same, okay, and you need to time reverse it. Okay, so we'll do it as h of minus k, and third step what we'll do, we'll keep fk as it is, and third step we'll shift this signal towards our actually right hand side, or delayed version will do. So we'll do like this. So it is also written as h of minus k plus n, and this actually we need to do or we can write here as h of n minus k, है ना? This we can write. And see, in convolution what we are doing, we are just multiplying fk into h n minus k. So here we are doing fk into h n minus k, okay, and we are summing it from minus infinite to infinite. This is called as y of n, है ना? So mathematically what we need to do, we need to just first change the domain, and then for fk and h of k, okay, both for both signal we need to change the domain, first step. Second step is you just reverse, means time reverse your hk and shift where, to the right hand side. So first you need to do reversal and then you need to shift. This is all about convolution, and if you can understand this basic concept now, then you'll able to solve discrete time LTI system, solve convolution property. It is the longest method which I am telling you to do graphical method, but after that